These are small neodymium magnets. They're spheres, and they can be used to build things like this icosahedron. The icosahedron is one of 5 Platonic solids. It has 20 triangles with 1, 2, 3, 4, 5 triangles meeting at each vertex. So it's a very, very beautiful shape. The magnets have interesting magnetic properties that puzzled me at first. A lot of people have a lot of fun with these magnets, building things, as we do in our particular family unit. One thing that puzzled me about the magnets is that if you imagine the end of this magnet, each of these magnets has a north pole and a south pole. And when you line them up in a chain, the north and south poles touch, because the north and south attract each other. So you get a chain like this. So you can be sure that at the end of the chain, this very tip of the chain will be either a north pole or a south pole. And I've checked, it's a north pole. So if you were to take 2 magnet chains and put them side by side, then we have 2 north poles here. You can imagine them repelling each other, and sure enough they do repel each other. But as soon as these magnets get to within about 1 magnet diameter of each other, they shift and attract each other. So now what you see is the north pole here is attracting the south pole of its neighbor. Shown here is what we call parallel connections. If you imagine these red halves, red hemispheres representing the north pole of the magnets, then the magnets shift off by half a magnet, and this north pole attracts this south pole, and this north pole attracts this south pole. So the peak of one magnet fits in this valley. Peaks fit into valleys. If you, the other way that you can connect these magnets up is to have a magnet chain that is now reversed. So I'm going to come back around the other way and connect them up this way. So now what we have is a north pole here and a south pole here. And this is what we call anti-parallel connections. So now we've got all the north poles for this chain on this side, all the north poles for this chain on this side. And that north pole attracts that south pole. And you can use them to form various shapes, an anti-parallel double ring like that. You can do the same thing with the parallel rings. It actually did it on its own. So there's a parallel ring with the peaks fitting into valleys of their neighbors. That's anti-parallel ring. I'm sorry, parallel ring. I said it right the first time. And then an anti-parallel ring here with peaks butting up against peaks.